Hello everyone and welcome to the lecture on AWS Transit Gateway. So this lecture will contain all these topics. What is AWS Transit Gateways? What can you attach? Maximum Transmission Unit MTU, Transit Gateway Route Table, Associations, Route Propagation, how Amazon VPC Transit Gateways work, Availability Zones, Route Tables, Routes for Peering Attachments, and Route Evaluation Order. So what is AWS Transit Gateways? AWS Transit Gateway is a managed network service that acts as a central hub for connecting multiple Amazon Virtual Private Cloud VPCs and on-premises networks. It functions as a highly scalable cloud router that simplifies network architecture and enables efficient traffic routing between different environments. As your cloud infrastructure expands globally, inter-region peering connects transit gateways together using AWS global infrastructure. All network traffic between AWS data centers is automatically encrypted at the physical layer. So what all can you attach? So you can attach one or more virtual private cloud VPCs. You can connect SD-WAN, wide area network third-party network appliance, and AWS Direct Connect gateway. You can attach a peering connection with another transit gateway. So two transit gateway can be paired together, same like VPCs can be paired. And you can attach a VPN connection to a transit gateway. So as you can see, transit gateway is basically a central hub for all kind of networking architectures, equipments, and topologies. And it is one of the most important network service in the all AWS network landscape. So next, maximum transmission unit. The maximum transmission unit MTU of a network connection is the size in bytes of the largest permissible packet that can be passed over the connection. The larger the MTU of a connection, the more data can be passed in a single packet. A transit gateway supports an MTU of 8,500 bytes for traffic between VPCs, Virtual Private Cloud, AWS Direct Connect, Transit Gateway Connect, and peering attachments, which is intra-region, inter-region, and also cloud wide area network peering attachments. But traffic over VPN connections can have an MTU of 1,500 bytes. So it is much lower than the actual, which is 8,500, because it's virtual private network and it will flow through the public internet. So that's why it has a lesser MTU. So transit gateway route table. A transit gateway has a default route table and can optionally have additional route tables. A route table includes dynamic and static routes that decide the next hop based on the destination IP address of the packet. The target of these routes could be any transit gateway attachment. By default, transit gateway attachments are associated with the default transit gateway route table. So next is associations. Each attachment is associated with exactly one route table, and each route table can be associated with 0 to many attachments. Route propagation. A VPC, VPN connection, or direct connect gateway can dynamically propagate routes to a transit gateway route table. With the connect attachment, the routes are propagated to a transit gateway route table by default. With a VPC, you must create static routes to send traffic to the transit gateway. With a VPN connection, routes are propagated from the transit gateway to your on-premises router using Border Gateway Protocol (BGP). With a direct connect gateway, allowed prefixes are originated to your on-premises router using BGP. With the peering attachment, you must create a static route in the transit gateway route table to point to the peering attachment. So how Amazon VPC transit gateways work? In AWS Transit Gateway, a transit gateway which acts as a regional virtual router for traffic flowing between your virtual private clouds, VPCs, and on-premises networks. A transit gateway scales elastically based on the volume of network traffic. Routing through a transit gateway operates at layer 3 where the packets are sent to a specific next hop attachment based on their destination IP addresses. The route table for each of these VPCs include the local route and the routes that send traffic destined for the other two VPCs to the transit gateway. Next, how it connects to or how it relates to availability zones. So when you attach a VPC to a transit gateway, you must enable one or more availability zones to be used by the transit gateway to route traffic to the resources in the VPC subnets. To enable each availability zone, you specify exactly one subnet. The transit gateway places a network interface in that subnet using one IP address from the subnet. After you enable an availability zone, traffic can be routed to all subnets in the VPC, not just the specified subnet or availability zone. However, only resources that reside in availability zones where there is a transit gateway attachment can reach the transit gateway. If traffic is sourced from an availability zone that the destination attachment is not present in, AWS Transit Gateway will internally route that traffic to a random availability zone where the attachment is present. There is no additional transit gateway charge for this type of cross-availability zone traffic. And it is recommended that you enable multiple availability zones to ensure availability. Okay, next is about route tables. So your transit gateway automatically comes with a default route table. By default, this route table is the default association route table and the default propagation route table. Alternatively, if you disable route propagation and route table association, AWS does not create a default route table for the transit gateway. You can create additional route tables for your transit gateway. This enables you to isolate subsets of attachments. Each attachment can be associated with one route table. An attachment can propagate its routes to one or more route tables. You can create a black hole route in your transit gateway route table that drops traffic that matches the route. When you attach a VPC to a transit gateway, you must add a route to your subnet route table in order for traffic to route through the transit gateway. So next, something about route propagation specifically. Transit gateway attachments can be configured with routes that can be installed in multiple route tables. Once an attachment is propagated to a route table, its routes are automatically installed, though filtering of advertised routes is not supported. When using VPC attachments, the VPC CIDR blocks are automatically propagated to the transit gateway route table, ensuring proper routing between the VPC and other connected networks. Dynamic routing enables both VPN attachments, virtual private network attachments, and direct connect gateway attachments to propagate routes learned from on-premises routers through BGP protocol, border gateway protocol, to any transit gateway route tables, and thus this facilitates flexible network connectivity. BGP advertisement. So BGP advertisement handles route distribution differently for various attachment types. VPN attachments advertise routes to customer gateways. Connect attachments share routes with third-party appliances like SD-WAN, and direct connect gateway attachments control route advertisement through allowed prefixes. In cases where both static and propagated routes exist for the same destination, static routes take precedence and are given higher priority. The propagated route is excluded until the static route is removed, at which point the propagated route becomes active in the route table. So routes for peering attachments. The peering setup. So this is between transit gateway and transit gateway. Two transit gateway being paired together, same like VPC, but this is applicable on transit gateways only. The pairing setup process begins by creating a peering attachment on your transit gateway and specifying the paired transit gateway with which you want to establish the peering connection. You must create a static route in your transit gateway route table that directs traffic to the transit gateway peering attachment, enabling communication between the paired gateways. Once configured, traffic can flow through the peering transit gateway and be routed to its associated VPC and VPN attachments, enabling comprehensive network connectivity across paired transit gateways. So next is route evaluation order. So transit gateway routes are evaluated in the following order: the most specific route for the destination address. For routes with the same CIDR but from different attachment types, the route priority is as follows. So first priority is static routes. So which you have configured like manually. You have given, okay, for this CIDR block, this is the device or the attachment that it should go to. For example, site-to-site VPN static routes. So this has the highest priority. Next is second priority is prefix list referenced routes. Third priority goes to VPC propagated routes. Fourth priority is direct connect gateway propagated routes. So propagated is something which is it has learned from one device and then it propagates, like it gets distributed over the network. So that we call as propagated routes. Fifth priority goes to transit gateway connect propagated routes. Sixth priority is site-to-site VPN over private direct connect propagated routes. Seventh priority is site-to-site VPN propagated routes. So this is VPN propagated route, but it is dynamic. It's not static. So first one is static, like which you have manually, because that is the highest priority. And number 8 is transit gateway peering propagated routes, which is applicable to cloud virtual wide area network. So across the country or across a bigger region. So that is wide area network. And that's the end. And that's all. Thanks for watching.